What's the value of sine inverse sine of 2 pi by 3? Now, pause the video, think about it. Alright, if you wanted to cancel sine inverse and sine, well, good news and bad news. Good news is we can do that if this angle is in the principal value branch, but we can't do that if that's not the case. Sine inverse has the output from minus pi by 2 to pi by 2, fourth quadrant and the first quadrant. 2 pi by 3 is not in that range, so we can't do that. We just can't cancel sine and its inverse. Not yet. Here's what we can do. We can figure out the value of sine 2 pi by 3 and then find sine inverse of that value. So this is not true. Sine inverse of sine of 2 pi by 3 is not equal to 2 pi by 3. But let's find the value of sine 2 pi by 3. Let's evaluate what's inside this inverse. So we have sine 2 pi by 3. That's sine of pi minus 2 pi by 3. We can apply trigo here. Sine of pi minus theta is equal to sine theta. This is sine of pi minus 2 pi by 3. That's sine of pi by 3. And sine of pi by 3, that's equal to root 3 by 2. This is 60 degrees. Sine 60 is root 3 by 2. So this is true. Sine of 2 pi by 3 is equal to root 3 by 2. So this is something that we can replace. We can write this problem as sine inverse root 3 by 2. Now our job is to find sine inverse of root 3 by 2. The range for sine inverse is fourth quadrant and first quadrant. Fourth quadrant for negative values and first quadrant for positive. This is positive. This means the angle that we're looking for is in the first quadrant. So the question is, for which angle theta in the first quadrant do we have sine theta equals to root 3 by 2? So that's something that we know. Sine theta is root 3 by 2 at pi by 3. This means that the theta that we're looking for is equal to pi by 3. The principal value for sine inverse root 3 by 2 is pi by 3, which means the solution for this is pi by 3. Let's try one more. Tan inverse tan of 3 pi by 4. Can we cancel tan inverse and tan? Think about it. Well, no, we can't, because 3 pi by 4 is in the second quadrant. And we can only cancel this if this angle is in first or fourth quadrant. That's the range for tan inverse. So let's evaluate what's inside tan inverse. That's tan 3 pi by 4. Tan of 3 pi by 4, tan of theta, that's equal to minus tan of pi minus theta. So that's going to be pi minus 3 pi by 4, that's pi by 4. This is minus tan pi by 4, that's minus 1. So tan 3 pi by 4 is equal to minus 1. Now let's plug minus 1 here. What we need to do is we need to find tan inverse of minus 1. Now what's tan inverse of minus 1? The range is first and fourth quadrant. First for positive values and fourth for negative. Because this is negative, we are looking for an angle that's in the fourth quadrant. So the question in front of us is, for which angle theta do we have tan theta is equal to minus 1, where theta is in the fourth quadrant? Let's think about it. Tan theta is 1 at pi by 4, which means it's minus 1 at minus pi by 4. This means our theta is minus pi by 4. That's the solution for this problem. Now in these two problems, we were able to figure out what was inside the inverse function. We could figure out the values of sine 2 pi by 3 and tan 3 pi by 4. What will we do in a scenario where we can't figure this out? Here's the problem. Sine inverse sine of 3 pi by 5. Now 3 pi by 5 is not a common angle. We can't easily evaluate what's inside the inverse. What should we do here? Pause the video, think about it. Okay, first let's ask ourselves, is 3 pi by 5 in the principal value branch? Is this in the first quadrant or the fourth quadrant? Well, no. 3 pi by 5 is more than pi by 2, so this means it's in the second quadrant. So 3 pi by 5 is in quadrant 2, which means two things. First, this sign is positive. Second, we can't really cancel this out right now. We can't cancel sine inverse with sine because this is quadrant 2, not quadrant 1 or quadrant 4. But at least we know that sine is positive. Whatever the value is, it's a positive value, and sine inverse of that positive value lies in quadrant 1. So at least we know that the answer to this problem lies in quadrant 1. That's a very important clue. We can convert this angle 3 pi by 5 into some other angle that's actually in quadrant 1. And then we will be able to cancel sine inverse and sine. So let's apply trigo to convert sine 3 pi by 5 into sine of some other angle which is in the first quadrant. Pause the video, try this on your own. Okay, here's how we do it. Sine 3 pi by 5 is equal to sine of pi minus 3 pi by 5. because sine of theta is equal to sine of pi minus theta. By subtracting this from pi, we're reducing it to something that's in the first quadrant. If you have something in the second quadrant and you subtract it from pi, you will get something in the first quadrant. You will get pi minus 3 pi by 5, 2 pi by 5 in this case. These two are identical, these two are equal. Sine 3 pi by 5 is same as sine 2 pi by 5. This one is not in the first quadrant, but this one is, which makes this really useful for us in this scenario. We can replace sine 3 pi by 5 by sine 2 pi by 5 and write this as sine inverse sine of 2 pi by 5. Switching 3 pi by 5 with 2 pi by 5 because both of these give the same sign. And now we need to evaluate this part, sine inverse sine of 2 pi by 5. This is something where we can cancel sine inverse and sine because 2 pi by 5 is in the principal value branch. So cancelling these two, we get 2 pi by 5 as the answer for this problem. Let's try one more. Cos inverse cos of 3 pi by 5. Pause the video, try this out. Alright, now 3 pi by 5, as we have discussed, is in quadrant 2, which is good for cos inverse because the range for cos inverse is quadrant 1 and quadrant 2. So in this case, we can really cancel these two out right away. So this angle is in the principal value branch. We can cancel these two. Our answer is 3 pi by 5. But what about tan? Tan inverse tan of 3 pi by 5. Pause the video. Try this one out as well. Okay. So this is in second quadrant. That does not work for tan inverse. We need something in the first or fourth quadrant. So we need to do conversions. How do you use Trigo to convert tan 3 pi by 5 into tan of something that's in first or fourth quadrant? Now 3 pi by 5 is in quadrant 2, which means tan is negative here, which means the answer lies in fourth quadrant. So how do we make 3 pi by 5 move to quadrant 4? We can subtract pi from it. Tan of theta is equal to tan of theta minus pi. We can add or subtract theta from an angle without changing its tan. So tan of 3 pi by 5 is same as tan of 3 pi by 5 minus pi. This reduces 3 pi by 5. This makes it minus 2 pi by 5. This value, this angle, minus 2 pi by 5 is in the fourth quadrant, which means it works for us. So we can replace tan 3 pi by 5 with tan of minus 2 pi by 5. In this case, we can't cancel these two, but in this case we can. So cancelling tan inverse and tan, we get minus 2 pi by 5 as the answer for this problem.